Part 5. Describe transformations. Let f of x equal the cube root of x. Now find a function g whose graph is obtained from f after the following sequence of transformations. So let's go through this step by step. First, we want to shift to the right 5 units. So if we're shifting to the right, we're changing the x coordinate. So we have an x minus 5 now in the cube root. Next, we want to vertically stretch by a factor of 3. So we're going to multiply the y coordinates by 3, or multiply what we have by 3. Now we have 3 times the cube root of x minus 5. Then shift down 4 units. Now we have 3 times the cube root of x minus 5 minus 4. And last, reflect about the x-axis. So shift that whole thing upside down. If I flip the whole thing upside down, I multiply the whole thing by -1. And I can distribute that -1 through if I would like, and I get -3 times the cube root of x minus 5 plus 4. And that is my new g of x, my new function. What would happen if I reverse steps 3 and 4? Let's look at that. At the end of step 2, I had 3 times the cube root of x minus 5. So now if I reflect about the x-axis, I have -3 times the cube root of x minus 5. And then if I shift down 4, I have -4. So we're close, but this function here has a +4, and this one has a -4, so they're not exactly the same. Let's try another example. Write a formula for a function g whose graph is obtained from the graph of f of x equals square root of x after the following sequence of transformations. So first, reflect about the y-axis. So that's when we multiply the x inside the function by -1. Then left 3 units. So now I have the square root of -x plus 3, or I could write this as the square root of -x minus 3. And then down 4 units. So my final function g of x is square root of -x minus 3, then -4. State the toolkit function and series of transformations to that function that are used to graph f of x equals 3 over x minus 1 plus 5. So our toolkit function is y equals 1 over square root of x. If we look at how the x changes, we have an x minus 1. So this function gets moved to the right 1. Then we multiply the function by 3. That's our 3 in the numerator. So that means we have a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. And then lastly, we move the graph up 5.